Most students make sections as the end product of their design, whereas these are an integral part of the design process. Building sections help in understanding heights of various architectural elements and also the design. Therefore, it is important that depictions in building sections are correct in two ways. First, they should be correct technically. Which means that they should document the correct construction method. Secondly, they should be correct dimensionally, which means that they should be made with proper heights. First, all walls finish under a slab. This is a very common situation which students miss when they are depicting the relationship between a wall and the slab. The next is that all buildings have plinth. All openings have a lintel on top which takes the load of the wall above. The next important thing is that conventionally all slabs have a beam which hangs down from them, and it comes at a regular interval and at the edges also. When a building is cut in section, some of the elements beyond the section plane are visible as elevation. This should always be shown. This helps in a better understanding of the situation at a floor level. And finally, all building elements have a certain thickness or dimension. Always depict that correctly. Now let us understand what is dimensional correctness. When we make a building section, all elements are drawn with reference to some important vertical datum. First, you should draw these datum as horizontal lines. Then you can build the section around them. These are important references or levels. Let us list these datum. Always make the ground line, then the plinth, top of the sill, bottom of the lintel, top of the first slab, top of the parapet wall. All these are basically identifying the heights of these elements, and the ground line is the base for these heights. There can also be a basement in the building, and that will also get identified with reference to the base, that is the ground. And if there are more floors, they may also have similar reference lines. Always make these datum lines first and then start detailing the section. Let us try making a building section. We will start the work by first making the datum lines or the reference lines. These lines will identify the important levels in the building. By making these lines, it becomes easier to relate to the two elements on the same level or different levels, especially when the building is long. It's a good idea to name these for any future reference. When you are working on a digital medium, you may make them on a non-printable layer. Also, identify the important edges of the building, like the extreme extent of any major building element, the walls, beam lines, etc. Setback lines or marginal open spaces is also an important edge. This helps you to check if the building element at all heights are within the permissible limits. Now start filling in information. First, by taking projections from the plan, then adding information according to the system of construction to be used. You may be taking load-bearing structure, frame structure with RCC slabs, frame structure with truss as roof, or a complete steel structure, or anything else. This is the thickness of the RCC slab. The ground floor will also have PCC base like the RCC slab above. This is a slab at intermediate level, at the level of the lintel, and there is this wall which completes the box. Now add the beams as per the structural drawing. Conventionally, the beams hang down from the slab. We also have inverted beams and sometimes flat slabs where the beams do not hang down as conventionally it is done. But to start, we will go by conventional practice only. Beams at plinth levels make a frame. Within this frame, filling is done so that the ground floor can be created. The periphery of this frame should be closed using a wall, a stone slab, or RCC curtain wall so that the filling in the plinth stays within. Let us now darken the building elements. What is the rule for darkening? Elements getting cut by a section plane are shown thicker, and elements behind, which are visible as elevation, are shown by thin line. The slab at this place is turning down and then again coming back to the original level. The lower slab is known as the sunken slab. It is useful in the toilets. This is a curtain wall in RCC hanging from the plinth beam. This will come in the periphery. Now let us add vertical elements like the walls, parapet walls, etc. This is a parapet wall which is complete in itself. Here below we have a shorter parapet wall which will have railing above for protection. Never miss a lintel at the top of any opening. Some of the external windows may also have weather protection or a chhajja. Always draw that. An alternative to RCC curtain wall can be a brick wall like this. Now, like the RCC slab on the upper floor, the PCC on the ground floor creates a hard base for the flooring on ground. Nowadays, nominal reinforcement bars are used on the ground floor also. But this is not like a regular slab. This is that railing on top of the short parapet wall. Here, I am using a thinner pin to make the elements visible as elevation behind. Sometimes the openings are so high that the beam or the slab above acts like a lintel, like in this case. Always show the jamb lines of the openings as they are visible in elevation at the back. As there is a veranda here, let us give a plinth beam here also. Out here there is a wall behind, whose edge will be visible at the back. Always show the ground line. It should be drawn using a thick line. It enhances the importance of this reference or datum in the whole drawing. The floor finish on the terrace should be laid such that the slope drains out all the water. But this may not be shown in the section. The edge of meeting of the parapet and the floor may be rounded to stop water from staying at the edge. Floor finish of terraces, balconies, verandas and the toilets may be lower than the finish of the regular floor at that level. These are the edges of the door jamb visible at the back. In a section, the important dimensions are that of the datum levels from ground and the floors. The important dimension between two floors is from top of one floor to the top of the other floor. This is known as floor to floor dimension. Then within floor to floor dimensions, you may break up the dimension into smaller important parts. Plans are for horizontal dimensions and sections are for vertical dimensions. But there are certain horizontal dimensions which cannot be depicted in plans. So here the width of the chhajja has to be shown in section. Let us darken another section to revise the typical situations you may have to draw in a building section. First, identify the datums. Always name your datum lines. When working on a digital medium, put the names on a non-printable layer so that it is available as reference but does not print. The plinth beams of the ground floor, the staircase tied to the plinth beam at ground so as to have a proper transfer of load onto the structure. Now the upper level conventional slab with its system of beams at the edge and the sunken slab wherever needed. Do not miss the smaller slabs like the chhaja or lofts, which may be acting like a lintel for an opening. You may also have inverted beams in some of the parts. At some places, there may be a cantilever projecting from a slab. All openings getting cut by section plane will also have a lintel at the top or a chhaja also acting like a lintel. Now darken the walls which are getting cut by the section plane using a thick line. If there is a staircase flight visible at the back, darken it as a unit visible as elevation. Darken the PCC base of the floor on ground using thick line. Now darken the units visible in elevation using a thin line. It is good to have a brick edging to all unapproachable floors, whereas all approachable terraces and verandas will have a parapet wall or a railing to secure them from falling off. This is a cutout which is open to sky and has mild steel security grille and a fiberglass or a similar material cover. All the elevational edges have also been drawn. All floor surface will have floor finish which is conventionally taken as 40 to 50 mm thick, including the base and the flooring material. All floors are laid at desired level and with the desired slope if needed. Now let us revise some of the important things to be kept in mind. Always show the ground in thick line. The floor resting on ground has to be filled and treated in a manner that it does not sink or settle down. It has layers of materials put in a sequence so that all spaces are filled conveniently and properly to ensure compacted space between the ground and the floor. The plinth beam comes under all the walls on the ground floor. Lintel is shown above all openings, getting cut in section. In some situations, slab can act as a lintel for an opening. Conventionally, all slabs will have a drop beam around the slab as per architectural and structural design. In some cases, depending on the need, we may also have an inverted beam. Toilets may have sunken slab to accommodate the drainage pipes and traps. Always draw the elements visible in elevation beyond the section plane. This should be drawn in thin lines. All approachable terraces and balconies should have a parapet wall or railing so as to secure the edge and prevent anybody from falling down. Unapproachable terraces should have one coarse or two coarse brick edging. It helps to channelize the drainage of water and also gives a proper width to the edge of the slab. The finishing on all floors may either be flat or sloping depending on the location and the use. The slope is given in the floor finish so as to drain out water, like in toilets and terraces. On upper level, the floors are made in reinforced cement concrete, whereas on ground, plain cement